Welcome to the Avaya FabricConnect Mentor Series. I'm Ed Kohler and I'm going to be your host for these short series of videos. What we're going to do is we're going to take a node that is pretty much defaulted, ERS 8804. We're going to set up shortest path bridging on the node. We're going to establish adjacencies to the rest of the FabricConnect network, and then we're going to go through and enable configuration and fault management, IP services, as well as Layer 2 and Layer 3 VSNs. All of the videos will be broken into a subject context so that you can go back in and review the appropriate CLI procedures to do each command subset.
In order to get our Ethernet switch to establish and attach connections into the existing Avaya FabricConnect network, we first have to set up shortest path bridging on the node. The next step after that is to set up and enable SPV and ISIS and the particular interfaces that are linking over to the other nodes in the FabricConnect network. That's the focus of this video. But before we do that, one of the things I like to change is the actual prompt value of the switch. And the reason why this is important to consider is that this, once you're through with the configuration, if you do it at this point, will become your ISIS system name. This is a human-readable, friendly value that you will see in the tables. And as you get out to very large SPV networks of hundreds of switches, being able to have that is an important thing. So you may want to give some thought to the actual label. It may be and should be specific to your environment and the methodology of tracking elements. That may be geographic or topological. For example, it could be based on subnets, departments, things of that nature. Or it could be based on physical values such as building numbers and closet numbers, hallways, things of that nature. Anyways, it's a specific label that you'll be able to look at in the database and say, okay, there's a physical node in the network, and I can now associate and match the logical services to that physical node. And you'll actually be able to see that in the link state database. So it's a fairly important step to give some thought to what that label is going to be. The next thing we want to do is set up and enable SPVM, and that's a fairly simple command. We just run the command SPVM, and it is basically running. Now, we need to establish some substrates for the Dijkstra algorithm that will be run by the shortest path bridging nodes using ISIS. These are termed as backbone VLANs. This is a universal value that has to match for every node within the domain. And it's important that you also establish the same primary for every single node within the domain. The other thing to note is that the type value that you specify when you set up the VLAN is quite a bit different. Rather than being by port or by protocol, it is type SPVM VLAN. Now, there's a little bit different methodology in how a port joins the actual backbone VLANs as well. In a normal VLAN environment, particularly when it's set up as a type by port, you usually would set up the VLAN and then go in and assign ports to that VLAN. This is quite a bit different here. This is a nodal global value. As a matter of fact, it's a domain-specific value that every node within the SPVM FabricConnect network needs to agree on. So it's important that you document that. And as you can see, we show that in our document that 3998 and 3999 will be our backbone VLANs, and 3998 will be our primary, and we'll show how we basically establish that through further CLI interaction with the node. Now, at this point, once we've set up our backbone VLANs, we're going to go into ISIS. And at this point, we're going to establish an association with the SPVM instance that we just created. So we're going to basically run the SPVM1 command, and that basically shows that we're running protocol. SPVM is the primary instantiation, and you will see that in the linked state database as we move further on through the course of the mentor videos. After that, we want to establish the nickname of the device. This is an important consideration as well. It is a hexadecimal 2.5 octet value And for all intents and purposes, this is the shortest path source ID. And that's an important consideration. As a matter of fact, that's actually the technical term that's used for the nickname within RFC 6329. This actually performs the role of multi-point replication and source identification. So number one, it has to be unique, and you have to make sure that you have an appropriate value for each and every node that you install and set up. So again, we're going to look and match what we show in our cut sheet value, that we're going to give this a nickname of 0.00.04. Now, once we're done with that step, we just need to go in and specify our primary BBID. So first of all, we're going to go in and specify that we do have two BBIDs that we set up as per previous, and that is 3998 and 3999. And then we want to establish our primary as well. And again, that has to agree with every node in the network. If you do not agree with that value, then the SPB node will not set up and establish successful adjacencies. And we're just going to specify that value as 3998. And we are now on to the next step, which is actually to set our system IDs and our manual area IDs. The system IDs are specific to the node, and the manual area ID is a global value. So what we're going to do now is we're going to go into router ISIS, and we are now going to set up our system ID. Now, the system ID is actually the BMAC. This is an optional command. It does not have to be done. If you did not implement and set up the system ID, it would actually create one on its own. However, for the purposes of this exercise, and given the fact that it is a mentor video, we're going to actually show and demonstrate how the command can be used. Another thing is that in conversations with customers, I found that many customers do want to set up and indicate what the system ID will be. The reason being is they now have the ability to take and match the prompt value to the system ID. Anyone implementing an SPB node that came up with a random hexadecimal value basically would stick out like a sore thumb. So it allows them to look at the link state database and have some added value of context. But in this case, again, we're going to reference what we show in the cut sheet and set up our system ID for 004400440044. Now, the last step that we really need to do is go in and set up our manual area ID. And again, this is a global value. This has to match for every ISIS node within the network. If they don't match, they will not set up and establish proper adjacencies. Now, once we have that done, we're ready to actually enable SPB. And at that point, it's fairly easy. Command of router ISIS enable. At that point in time, we have SPB set up. So as you can see, in a very short sequence of command lines, we've actually set up shortest path bridging on the FabricConnect node. However, it's not a true FabricConnect node yet. If we do a show ISIS, we show that we do indeed have ISIS enabled. We show that we do have a system ID. We show our correct router name. However, if I do a show ISIS LSDB, we see that we are the only node in the network. And if I run that command further with a detail, this gives me what is called a standalone skeleton link state database. This gives me the primitive type length values to set up and establish an SPB node. So we have TLV1. We obviously have our BMAC information and ISIS system ID. We have our lower level TLV values, which basically tell us our area address, our supported protocol, the actual host name of the device, as well as the backbone BBIDs that we have set up and established in the environment. So this is basically, takes us through step one. The next thing we need to go and do is set up and establish connection into the rest of the FabricConnect network. And that actually is a fairly easy thing to do. So we're just going to go in and specify interfaces, and we're going to reference again our cut sheet diagram and see that we're going to use port 1 slot or slot 1 port 2 and slot 1 port 18. So slot 1 port 2 and slot 1 port 18. Now, once we're into the actual interface configuration module, we just specify ISIS. And at that point, we specify the ISIS instance we want to run, which is SPBM1. And at that point, we just do ISIS enable. Now, it's important to note that these ports are in a shutdown mode. And that's typical. In the lab, we do that to prevent loops for ports that have connections between nodes, but don't have the appropriate protocols to prevent loops yet. So what we want to do is just run a no-shut command on these interfaces. And at that point in time, what we'll see is that we will start to establish adjacencies. So if I now do a show ISIS interface, and first of all, let me exit this command. Now we'll do a show ISIS interface. We will see that we now have SPB and ISIS established on both ports. We see that the operational state is up, the admin state is up. Now the next thing we want to do is check which nodes we're connected to. So we will do the show ISIS adjacency command, and we can shorten that with just show ISIS ADJ. And basically what we see is that we are connected up from port 1, 2 to node 003300330033 and port 118 up to 001. And as we can see and reference the diagram, we can see that that topologically is correct. This does match the deployment scenario. Now, if we actually run the same ISIS link state database command, we will see that it is fleshed out a little bit. This is what I refer to as a skeleton link state database. As you can see, we are now able to see other nodes within the network. The first one we see is the ERS-8800-1, and basically it's reporting all of its type length values into our database. So as you can see, we can move down and see that the backbone BBIDs and everything are corresponding for every node within the network infrastructure. And as we can move down through, we can see that we are now showing ERS-8800-2, and we can also see that ERS-8800-2 also has particular instances that are provisioned, such as L2 VSNs as well as L3 VSNs. And we will establish connections over to the other side of the network because as you can see, we have two backbone core bridges between our nodes, and that will be a course of videos throughout the Mentor series. But as you can see, we now have an established connection into the network. It's up and running, and we're ready to go on to the next steps.